So here's a couple examples of different design software outputs. The Ekahau one, I've got a few pictures here overlaying each other, and here you can actually see the path, the black lines in the blue area, as well as the green lines in the yellow orange area. Those are actually the path that the engineer walked to gather data, produce this heat map. So if there's an area that you were unable to, the engineer is unable to walk into to gather coverage, you know that coverage projected in that drawing is estimated. So it's virtually calculating what the coverage is in that space, whereas on the left you have no idea where they walked, so you don't know what's predicted coverage and what is actual measured coverage. You can also see the grading in the colors between the two is not nearly as nice. And Ekahau has a lot of features like spectrum analyzer. You've got at the top, I don't know if you can see it, but there's green boxes and there's a red box at the top of that the large screen there on the Ekahau side. And as you're doing a survey, it'll actually tell you, hey, this particular spec is not being met where you're currently standing. And so that way you can address it and maybe figure out why you're not meeting the requirements for the design in the area. So here at NSI, we use Ekahau Pro, and it is recognized as the best survey software out there. It's also not cheap, which is why a lot of the competition does not use it. But to get the best results, you need the best tools. So here's a couple more images of design outputs. So poor design, quite often, if you've gotten a poor report from a competitor, you might just see a map with a blob of green on it and say, yep, here you go, you got coverage everywhere. And that really doesn't tell you anything. So you don't have things like what was their transit power when they set up their test APs? What power should you set your APs up to when you deploy your new APs? What antenna type should you use? Locations of the APs should be visible in the gradients of the colors. They'll usually mark the map with numbers to show you, we're going to put an AP here, here, and here. Whereas Ekahau, it has the numbers as well. This is just a single image out of Ekahau. It's actually usually like 20 or 30 page report, depending on how many floors and stuff like that. Sometimes it can be in the hundreds of pages if it's a large building. So you get lots and lots of information about what is it going to take to deploy your network. And then you can also say, let's say, for example, you don't get a post-site survey after your install is done to verify the coverages are all what you expect. You can still look at the design report and say, for example, on this map on the right, which will be one of your output pages, you can see there's a couple gray specks. So you're like, okay, well, the coverage in that area was a little bit on the weak side, and that's where they're complaining. So I probably should go check the coverage over there and make sure it's actually matching. If it's not, then I probably need to adjust, move an AP a little bit or adjust the transit power to get it where it needs to be. So you can actually go back to your reports and do those kind of things based off of design. We would also provide recommended transit powers and channels per AP details. There's going to be different maps. This particular one's a 5 gigahertz band coverage. So you have another one that looks just like this. That's for 2.4 gigahertz. And you'd be able to see the edge of the cells and stuff. So there's just a lot more information you would get from that output. This slide is basically just to show you the coverage at 1024 Qualm. These APs are turned up all the way, and there's drywall walls that have been drawn in here. The idea is that if it was 256 Qualm, you'd see the green touching between the access points, but you see on 1024 it does not. So as the Qualm data rates go up, your coverage is going to go down. So in the typical deployment, you wouldn't have your APs turned up all the way, and to get 1024, you're going to need more or less line of sight to your AP. So it's just showing that as you go up in data rates, your coverage area goes down. So that's about it there. So RF design is recommended when adding or removing large amounts of shelvings or walls. Basically what you're doing there is you're going to be changing the coverage patterns from your APs, which may require moving APs to still provide the same level of coverage that you had before and prevent other unusual issues you may run into. Experiencing poor roaming, voice quality, inconsistent performance. These are all signs that there's something wrong with the RF design in your wireless network. Providing wireless for a new area. So let's say you're setting up a new building, or you've done complete renovation or something like that. It would be considered a new area. So you need to get into RF design for that. Significant changes in wireless devices or quantities of devices. So let's say your old design was designed for some really old wireless phones that were G only or A and G only, but they didn't support N or AX or anything like that. There may have been some things about the design that were done just for the purpose of supporting those devices and are no longer necessary for your new devices. The devices in your network are half of your network, the APs are the other half. So what you have in your network is as important as the wireless network that you deploy, and they need to be taken into account during the design.